Good morning. This is our last lesson before our review and our test for Chapter 4. It is on graphing linear functions. Now, we have seen functions written in the form y equals mx plus b, like it says here. But by naming a function f, we can write it using function notation. So function notation just means solving for y. So I like to think of this f of x as a fancy way of just writing y. So we can just put a y there if we would prefer to do that instead. Like, for example, in Spanish, you might call Miss Schifferly Senorita Schifferly instead of just Miss Schifferly. It's just a fancy way of saying the same thing. Alright, so it says the symbol f and then in parentheses x is another name for y and is read as the value of f at x, or just simply f of x. It does not mean f times x. You can use letters other than f, such as g, for like example, g of x, or h of x if you would like. So it says evaluate the function when x equals -3, 0, and 2. So like before we made xy tables, and we plugged in -2, -1, 0, 1, and 2, the beginning of this chapter, we're doing that same thing now, but they just want us to plug in 3 random numbers. Okay? So first, we are going to plug in to this equation. Again, this is really just y equals 10x plus 3. For x, we're going to plug in first a -3, then 0, then 2. So first we're going to plug in -3, then 0, then 2. So first it says y equals 10 times x, and x is going to be a -3 plus 3. Well, 10 times -3 is -30. And -30 plus 3, there are more negatives. It's not -33 because this is a positive. It's really a -27. If you're not sure, plug it in your calculator. So there's one answer. Then we're going to plug in a 0. Y equals 10 times 0 plus 3. Well, anything times 0 is 0. So we just have 0 plus 3, which is 3. And then last, plug in a 2. Y equals 10 times x, which is 2, plus 3. Well, 10 times 2 is 20. And 20 plus 3 gives us 23. So there we have our 3 answers. We're going to do the same thing over here with this one. Instead of f of x, it says m of x, which is still a fancy way of just saying y. We're going to plug in those same 3 numbers, -3, 0, and 2. So first it says y equals -3.2 times x, which is -3. I know a negative times a negative is going to make a positive. If I multiply this by 3, well, 2 times 3 is 6, and 3 times 3 is 9, so it should give me 9.6. If I plug in a 0, -3.2 times 0, well, anything times 0 is 0. So that one's easy. And then last, -3.2 times 2. So we're just going to double it. It's still going to be negative. If I double 3.2, it should give me 6.4. If you're not sure, plug it in your calculator. So those are my 3 answers here. Now it says find the value of x, so we need to figure out what x is in our equation. Remember, this isn't really x, this is really y, so that the function has the given value. So here it says y equals 4x plus 3. That's the end of our equation, and here is 9. So when it's equal to or is given the value of 9. Whoa, crazy. Let's fix that. So they're telling us to plug in a 9 for the letter y because they're asking us to find x. We can't plug it in for x if we want to find x. So it would say y equals 4x. Now I'm messing up. Let's try that again. Y is really going to be 9 equals 4x plus 3. There we go. We plugged in a 9 for y. And now we're just going to solve this. We know how to solve this type of equation. Always get rid of your addition or subtraction first. We're doing the order of operations backwards, so subtract 3. We get 4x equals 9 minus 3 is 6. And then divide by 4. 6 divided by 4. We could simplify that to 3 over 2. But if I plug that in my calculator, it would give me 1.5. Alright. Next one, again, this is just a fancy way of saying y. We can change all of these right now, y. And now we're going to plug in, when y is 31.9, what is x going to be? So 31.9 equals 3.3x minus 1.1. So let's solve. Just like the other one, get rid of your addition or subtraction first. So I'm going to add 1.1. Those eliminate. We have 3.3x. And adding this up, 9 plus 1 is 10. Oops, that's a 1 there. 1 plus 1 plus 1 is 3. So we have 33 exactly. And then the opposite of multiplying by 3.3 is divide by 3.3. So we have x equals 33 divided by 3.3 should give us a nice 10. And last one, plugging in a 20 here for y. So 20 equals negative 5x plus 10. Solve this for x, get rid of your addition or subtraction, subtract 10. So 20 minus 10 is 10. And we have negative 5x left over. And last, the opposite of multiplying is divide. Divide by negative 5. And we get x equals now a negative 2. Alright, third one here. It says, the gray wolf population in central Idaho was monitored over several years for a project aimed at boosting the number of wolves. That's cool information, but we don't really need that, so I'm going to cross that out. It says the number of wolves can be modeled by the function, okay, f of x, which is just a fancy way of saying y. Y equals 37x plus 7, where x is the number of years since 1995. Graph the function and identify domain and range. Well, since 1995, well, if I plug in a 0 for x, that would still be the year 1995. But since 95, if it's been 1 year, that would be 1996. And then after 2 years, that would be 1997. So we're going to plug in these numbers. They only gave us 3 spots, so we're just going to plug in 3 numbers. We can't have negative years, so that's why we started at 0. So in our equation right here, it's, and remember f of x is just y. Ooh, my pen's going crazy today. Come on, try that again. Y, there we go. Y equals, and then 37 times x, and x is first 0. Goodness. There we go. So anything times 0 is 0. So 0 plus 7 is just 7. Then if we plug in a 1, y equals 37 times 1 plus 7. Well, that's just 37 plus 7. That should give us 44. And then plugging in a 2, y equals 37 times 2 plus 7. Well, 37 times 2, if I double that, 14, 60, 74 plus 7. 74 plus 7 would give me 81. My pen does not like me today. 81. There we go. So we have our graph, or our points. Now we can plot them. This down here, I'm going to try that again, is going to be my x-axis. This is going to be my y-axis because everything is positive. I don't need any of the other quadrants except these ones. I'm going to move this over a little bit so I have some space here. So we need to plot this. On my x-axis, I have years. So years would be 0, 1, 2, 3, 4. Remember, 0 would be really the year 1995, and so on, 1996. And then on our y-axis, I need to get at least up to 80. So if I go by 1s, it's not going to work. 5s isn't going to work. 10s, well, I'll only get to like 50, so I'm going to go by 20s. 20, 40, 60, if I can write. 60, 80, and 100. And plot my points. At 0 years, we are up 7, so a little bit less than 10. And then at 1 year, I'm up 44, a little bit more than 40 there. And at 2 years, I'm at 81. So I'm going to draw my line through here and put an arrow on it, because I could have plotted more points up to the right, but I can't go negative years below 1995 because that's where they told us to start. And then it simply says identify the domain and the range. Reminder, domain is what we plugged in. We plugged in numbers greater than 0. So I'm going to say our our x values, because we plugged things in for x. X is greater than or equal to, it's not like an L, 0. Because all of our numbers were greater than or equal to 0. And that's what we see here as well. They're all greater than or equal to 0. Then our range, our y values, we started at 7 and went up. So they are also greater than or equal to 7. If we stopped at the other end, we could say we're less than another number, but we could just keep going up because years keep going on and on and on. Alright, next. The number of hours people in the United States spent playing video games each year from 1998 to 2001 can be modeled by the function f of x equals 11.9x plus 46.4, where x is a number of years since 1998. First it says graph the function. So we can graph, we know how to graph in the form y equals mx plus b. We also know how to graph by making a table. We also know how to graph by making or finding our x-intercept and our y-intercept. You get to choose. I am going to graph using y equals mx plus b, because this is really y. So our b, where we're beginning, is really 46.4. So that's a little bit more than 40, a little bit less than 50. And our slope is 11.9 over 1. Now, we can't really graph 11.9 on here, so do your best guess. I'm going to go up 10 and 1 more, and then over 1. Up 10, 1 more, and over 1. Up 10, 1 more, over 1. Because we're really going up 11. That's why I'm going 1 more. So I'm going to draw my line through there, and know that that's just a really close guess. I could have gotten a lot better numbers had I made a table and plugged in year 0, 1, 2. That would have been more exact. So there's our equation. Identify its domain and range. Our domain, what we plugged in, were all the numbers greater than 1. So our x values are greater than or equal to 1. And then our range, our y values, they started at 46.4 and only went up. We didn't have any that were less than 40. So our y values are greater than or equal to 46.4. Now it says find the value of f of x, which is really y. Find y when x is 2. Now you could look at your table, but it's not exact, so I'm going to really use our equation. So when x is 2, let's plug this in. Y equals 11.9 times x, which is 2, and then add 46.4. All I did was rewrite this equation up here. So I'm going to plug that in my calculator. 11.9 times 2 gives me 23.8, and then I'm going to add 46.4. And I get 70.2. So what this is telling us, they said to plug in when x is 2, and x is a year. So in 2 years after 1998, that would be year 2000. So you could say in the year 2000, as it says explain, the number of hours spent playing video games is, I'm just going to say the number of hours is 70.2. So that's what that 70.2 means. Now it says find x. We want to know what is x, how many years is it going to be when y is 60, or when the number of video games that we play is 60 hours. So let's plug in y is 60, and then the rest of the equation, 11.9x plus 46.4. Same equation from up here. We need to figure out what year is that. Let's solve. So solving for x, I'm going to subtract 46.4. Those are gone. We have 11.9x. And in my calculator, 60 minus 46.4 gives me 13.6. And then last, the opposite of multiply is divide. Not going to be a nice number. 13.6 divided by 11.9 gives me about 1.14. It would go on. So that means after 1 year, so from January to January would be 1 year, so maybe in February of the second year, so of 1998, of 1999, of year 1999, the hours were 60. All right, we got a couple more things to do. Hopefully the second half of this lesson goes a little bit quicker. In the second half, we are talking about families of functions. Most of us have some things that are similar to our families, whether it be your hair, your smile, you have the same eyes or the same eye color, or maybe you all have similar characteristics in terms of you all have really short eyelashes, or you all love Italian food. Whatever it might be, you might have some things in common with your family. Our families of functions are equations that have similar characteristics as well. For example, functions that have the form f of x equals mx plus b or y equals mx plus b constitute the family of linear functions. So all the lines. The most basic linear function in all the families of linear functions is called the parent linear function, which is really just y equals x. This is in the form y equals mx plus b. Our m, our slope, is really a 1, and our b, our y-intercept, is really 0. Oops, come on, 0. So our slope, like we just said, would be 1, or as a fraction, 1 over 1. This is our parent function, which we are going to compare all of our graphs to. It starts at 0 and has a slope of 1 over 1. So rise 1, run 1. Goodness, why is my pen not working today? There we go. That's how we create this line, and that's what we're going to compare all of our lines to. We call this line f of x. Alright, so let's take a look at some lines. It says graph the function and compare it with the graph f of x, or y equals 1x plus 0. So I'm going to graph my parent function right away. I know it starts at 0 right here, plus 0. And my slope is 1 over 1. Rise 1, run 1. Or down 1, 1 to the left. This is my parent function. I'm going to put the f of x on here so I know that is my parent function. That is what we're going to compare this second line to. So this is also y equals 1x plus 3. So this one, we're beginning at 3. 1, 2, 3 on our y-axis. And my slope is 1 over 1. So rise 1, run 1. Now I can see that these have the same slope. that is something we are going to have to compare in a minute. So draw your line. I'm going to label this one g of x so that I can tell them apart, so I know which one's which. If you want to use colored pencils to do one in red and one in blue, or whatever color you'd like, so you can tell them apart, that would be a good idea. But it says this word compare, so I need to just do that, compare. We have two things to compare because they're in this form, y equals mx plus b. We can compare m, and we can compare b. Reminder, m is our slope. Now you can either look at our equations for our slope, here's 1 over 1, here's 1 over 1, or you can look at our graph. You can tell that these have the same slope. You always need to tell me first, is something the same or is it different? And if it's different, how is it different? So that might be something you want to write down here. Is it the same or different? And if it's different, you need to tell me how. So it's the same slope. If you want to put the word parallel, you can. That would be more specific. That's good. And then our b is our y-intercept. Do these cross the y-axis at the same point or different points? Well, these are definitely different. So I'm just going to write different, I'm going to shorten it, different y-intercept. And if it's different, we need to say, how is it different? Well, this new graph, compared to our old parent graph, is moved up 1, 2, 3. So we're going to say, moved up 3 units. Now, your book might use the word translated or shifted, but we can tell that all of those words mean that we're just moving our graph up 3 units. We're taking it from, we're taking it from here and we're going up 1, 2, 3. It got moved up. Let's graph this next one over here. Always first, graph your parent function, right here. Starting at 0, our slope is rise 1, run 1. Rise 1, run 1. Or down 1, 1 to the left. So there's my line. And we have our second function we need to graph. This one is y equals 2x plus 0, because there's nothing there. We know it goes to the origin at 0. And my slope is 2 over 1. So rise 2, run 1. Rise 2, run 1. Or down 2, 1 to the left. And draw your line through there. And then we are going to compare our new graph to our old parent graph. Okay, parent function. Two things we always need to compare are m and our b. Our m is our slope. Do these have the same slope? Well, you can tell just by looking at them that they're different. So I'm just going to write different slope. But if it's different, we need to say, how is it different? Now, I like to think of our old parent function as a sledding hill. If we're going to go sledding down this hill over and over and over again, but then we get to go to this new hill, this hill is, going to be so much faster. So you can either write the word faster, or that hill is also steeper. You're going to go down a lot quicker because it's a steep hill. The angle is bigger, okay? And then our second thing, comparing our y-intercept, these cross the y-axis at these same points. You can just write same y-intercept. Same y-intercept. All right, we have two more that we need to graph. We are going to also compare it to the parent function like we did before. That's what we're doing here. This is really y equals 1x plus 0. So let's graph that first. I'm going to graph my parent function on both graphs right away. Y equals 1x plus 0. My pen does not like me today. So starting at 0, our slope is 1 over 1. I'm going to graph this on both graphs. Hopefully this is one that you have memorized that you can just graph without needing to know what the parent function is. If you need to pause the video to make a nice straight line, feel free to do so. But I'm going to label this f of x, that's my parent function. And then compare whatever graph they gave us. This one is y equals negative 1/4 x plus 0. I put the negative on top because the negative needs to go with one of the two numbers, but not with both. So this one we're beginning at 0. And my slope is negative 1, so down 1, and positive 4, which is to the right. I can't go any further, so the opposite of down and right would be up and left. So there's that line. And put my arrows on there. And then we just need to compare. Compare M and B. Now our M is our slope. Do these have the same slope? Well, just by looking at them, they're not parallel, so they have different slopes. Different slopes. And if something's different, we need to say, how is it different? So let's take a look. If we go sledding down this hill all the time, and then we go sledding down this red hill, this one is going to be a lot flatter or slower. Flatter or a slower hill. But you guys, this red hill isn't even going the same direction. It is flipped the wrong way. We also have to add one more word here, which is that it's a reflection. That means that our slope is going the opposite direction. This one's negative and this one is positive. So I like to think, well, our sledders are going to collide. It's a reflection. They're going the wrong way. Our hill is flipped backwards. And then our B, our y-intercept, these two cross the y-axis at the same point. So it's the same y-intercept. All right, last one here. Y equals negative 2x, make it a fraction so we can graph it, plus 4. So our B, our y-intercept is 4, right there. And our slope is negative 2, so down 2. And 1 to the right is positive 1. Down 2, 1 to the right, or up 2, 1 to the left. I know I'm going a little bit quick, so if you need to stop and pause it, feel free to do so. So compare M and B. M equals and B equals. Our M is our slope. Right away, I know that they are different slopes. If they're different, we need to say how. If I'm going sledding here and now I'm going sledding over here, well, this new green line is steeper. Steeper, or a faster hill. If you're not sure, look at the slopes. This one's a slope of 2, this one's a slope of 1. 2 is greater than 1, so would the hill. This hill would also be greater. The negative means that it's reflected. The hills are going the wrong way. So this is also another one. Wow, don't mind my writing here. Reflected. And then our M is our slope. We're done with that. Our B is our y-intercept. These do not cross at the same point on our y-axis. This one's crossing at 0, and this one's crossing at 1, 2, 3, 4. So we have a different y-intercept. And it is really moved up 1, 2, 3, 4. So we could say moved up 4, or shifted up 4, or translated up 4. Moved up 4 units. We do have one last question. This first part is just talking about our families of functions. It's a review, saying the blue line is our parent function. This is translated up 2 units. This is translated down 3 units. Same thing here. Here's our parent function. This line is a steep hill. This line is a flat hill. And same thing here. These ones are just reflected. They're hills that are going the opposite direction. Okay? you can read the words that go with those as well. But now we have one problem left. It says match the function with the description. Here we have y equals 7x, so this would be a really steep hill. Here we have y equals x plus 7. This plus 7 means it's going to be moved up 7. And this one, 1x minus 7, means it's going to be moved down 7. So just match it with the words. A graph shifted up 7. Well, moved up 7 was this one right here, moved up 7. So that goes with A right there. Shifted down 7. Well, if we're going down 7, that means we need to have a minus there. So that goes with this one. So that would be B. And that leaves this last one, a graph dilated by a factor of 7. Dilated means our slope is tilted from that parent function up to be a lot steeper by a factor of 7, which would go with this one over here. So C goes over here.